So what does the constant k do in the equation y equals the absolute value of x plus k? To figure out the purpose of this k, let's start by looking at the parent function for this equation. Since we're dealing with an absolute value equation, the parent function is the equation y equals the absolute value of x. Let's graph this equation. Well, that equation has a vertex at the point 0, 0. Then the graph looks like this. This is the graph of the equation y equals the absolute value of x. Now again, the vertex is at the point 0, 0. And if we look to the left of the vertex, or when x is less than 0, we can see that the slope is -1. If we look to the right of our vertex, or where x is greater than 0, we have a slope of 1. Now that we have an idea about this parent function, let's play around with k a little bit. So let's pick a value for k. Let's say that this constant k equals 1. Okay, well then our equation would look like this. Y equals the absolute value of x plus 1, since we're having k be positive 1. Now let's take this equation and graph it. To do that, we need to make a table of x and y values that we can put together and make ordered pairs that we can use to graph. So let's make a table. We'll have a column for chosen x values. Then we'll want to take those x values and plug them into our equation. So, plug them into the absolute value of x plus 1. Then we will simplify to get our y values. Now let's pick some x values to use in this table. Let's have x be -2, -1, 0, 1, and 2. Perfect! Now we need to take each of these x values individually and plug them into our equation. When x is -2, we will have the absolute value of -2 plus 1. When x is -1, we have the absolute value of -1 plus 1. When x is 0, we have the absolute value of 0 plus 1. Then the absolute value of 1 plus 1, and the absolute value of 2 plus 1. Perfect! Now to get our corresponding y values, we need to simplify each of these expressions in the second column. When we take the absolute value of -2, we get 2. So here we really have 2 plus 1. 2 plus 1 is 3. So that is our y value. Here, the absolute value of -1 is 1. So we're taking 1 plus 1. We would get 2. Here, 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. Great. Now we have our chosen x values and their corresponding y values. Let's plot these and make our graph. When x is -2, y is 3. So we have the ordered pair -2, 3, right here. Then, when x is -1, y is 2. So we have the ordered pair -1, 2. Then we have the ordered pair 0, 1, 1, 2, and 2, 3. Then we put those points together and we get this graph. This is the graph of the equation y equals the absolute value of x plus 1. Now let's take these two graphs and compare them. Here again, with our parent function graph, we had a vertex of 0, 0. Here, in our new graph, our vertex is the point 0, 1. So, the y value of our vertex increased by 1. And if we take a closer look, these graphs are the same shape and size. To the left of this vertex, we have a slope of -1. And to the right of the vertex, we have a slope of 1. So basically, these graphs are the same. All we did was take our original graph and shift it up 1 unit. Now to get some more information about k, let's pick another value for k. Here, let's have k be a negative number. Let's have k be -1. Well, if k is -1, then our equation will be y equals the absolute value of x minus 1. Let's graph this equation. Again, we need a table. So, we'll have a column for our x values. a column for plugging those x values into our equation, and a column for the y values we will get. For comparison purposes, let's pick the same x values we chose in this table. So let's have x be -2, -1, 0, 1, and 2. Perfect. Now when x is -2, we will have the absolute value of -2 minus 1. When x is -1, we have the absolute value of -1 minus 1. Then the absolute value of 0 minus 1, the absolute value of 1 minus 1, and the absolute value of 2 minus 1. Then we simplify each of these expressions to get our y values. Here again, the absolute value of -2 is 2. So we're taking 2 minus 1. 2 minus 1 is 1. Then here, the absolute value of -1 is 1. So we take 1 minus 1, and we get 0. Then 0 minus 1 is -1. 1 minus 1 is 0. And 2 minus 1 is 1. Perfect. Now we can plot these points and make our graph. Here, when x is -2, we found y to be 1. So we have the ordered pair -2, 1. Then, when x is -1, y is 0. So we have the ordered pair -1, 0. Then here, x is 0 and y is -1. So we have 0, -1. Then we also have 1, 0 and 2, 1. We put these points together and we get the graph of the equation y equals the absolute value of x minus 1. Now let's compare this graph to the graph of our parent function. Again, here's our parent function, y equals the absolute value of x. It has a vertex of 0, 0. In our new graph, our vertex is the point 0, -1. And these graphs are the same shape and size. All we did was take our parent function graph and shift it down 1 unit. When k was a +1, our graph shifted up 1 unit. When k was -1, our graph shifted down 1 unit. That value of k determines how much we shift our graph up or down on the coordinate plane. That is called a vertical translation. So k controls our vertical translation. So now we take a look at this general equation. We have y equals the absolute value of x plus k. K is that vertical translation. It determines how much we shift our graph up or down. Now, if we have a positive value for k, then we will shift our graph up, just like we did in step number 2. On the other hand, if we have a negative value for k, like we did in step number 3, then we will perform a vertical shift down. And now we know the purpose of that constant k. In this equation, the constant k determines the vertical translation. How far up or down we will shift our graph on the coordinate plane.